I'm going to cover four types of problems very quickly, and I encourage you to pause the video so that you may practice on your own and then self-assess by continuing the video and seeing if you completed it the way I did. I'll also include a few hints as to strategies that will keep you organized and allow you to attend to precision. So the first type of problem, again, we're going to be adding imaginary numbers to real numbers. They're all part of the family of complex numbers, but imaginary numbers have the I attached to it. It looks like 5 is the coefficient of I, but 5i is an imaginary value. Real numbers 5, -4, and +6 can be combined. And one strategy is to arrange these or rearrange them so that reals go with reals and the imaginary go with the imaginaries. So if we combine 5, -4, and 6, we have 7, and we have a lone imaginary value of 5i. If we had other values of I, we could combine those with the 5i, but at this point we do not. So your solution is 7 plus 5i. Now here's a convention you need to recall or need to remember if it's not, if I haven't taught it. And that is the real values in the complex number, the real values, and this is a complex number itself. It just happens to be a binomial. Real values go first, and then we add the imaginary part. Okay, so this is the solution. Fairly straightforward. Problem number 2, notice we have parentheses. Here is where you need to attend to the value, sorry, the sign in front of the parentheses. This is very much like adding functions and subtracting functions. If you subtract one function from another and one of those functions is being subtracted is a binomial or has more than one term, you need to distribute that negative to both the terms inside the parentheses. So we can rewrite this as -1, subtract 7i, subtract 4, and subtract 8i. Now, using the same strategy as problem 1, you can identify the reals. Real values add up to a -5. Identify the imaginary parts, and they combine for a -15i. Problem 3. 3 is a product of two binomials. It's a binomial squared. So the first step would be to rewrite it as 6 subtract I times 6 subtract I. And now you need to use FOIL. Okay, so first, outside, inside, last, the product of those, it's double distribution. And so it's the first terms, the outside, the inside, and the last. Now there's going to be one more step here, because when we have the product of I and another I, you have I squared, and I squared simplifies to a -1. We'll demonstrate that in a moment. Product of 6's, we have 36. We have -6i, another -6i, and we have the product -i times -i, which is a positive I squared. These two can be combined. We have a -12i. I squared is simply -1, and 36 is 36. Combine the 36 and the -1, you get 35. Subtract 12i. Now, anytime you find the product, or you're gonna figure out the product of i's, you need to return to this rule. I is defined as the square root of -1 or radical -1. I squared is the square of those two values, so it's the same as the square of the radical -1, which undoes the radical and just leaves you with -1. I to the third power is the product of 3, so it's I squared, which is -1, times 1 more radical -1, which gives you -I. And I to the fourth power is the same as the product of I squared and I squared. So if I squared is -1, the product of -1 and -1 is a +1. And when you get to I to the fifth, I to the sixth, I to the seventh, I to the eighth, you repeat. This pattern repeats. So I to the fifth is I to the sixth is the same as I squared. I to the seventh is the same as I to the third, and I to the eighth, or anything that 4 will go into evenly, is always going to be 1. So it's I to the fourth, I to the eighth, I to the 12th, I to the 16th, and so on. One last problem. The product of 3. So you're going to take these in parts. My suggestion is to take monomials. 6i times -6i, you find the product of the reals and the product of the imaginary parts. So this is 6 times I times -6 times I. Rearrange them, I have 6 times -6, which is -36. I times I is I squared is equal to -1. So this is -36 times a -1 times 1 plus 5i. So we're not quite done here. -1 times -36 is a +36. Now I'm dealing with one value again. Notice what happens here. We have the product of 2 monomials. Both include I, so I'm going to end up with a real number. And it's that real number times 1 plus 5i gives me 36. 36 times 5. 5 times 30, 150. 5 times 6 is 30. 150 plus 30 is 180. Review these problems, do the practice. These problems for 5A, the earlier video, and 5B, this video, are identical, with the one exception is the numbers and the arrangement, but these problems are identical to the type of problems that you'll receive, you will take on the test. Please practice.